Hey everyone, Nathan Reedy here. I'm making this video because a granddaughter of one of my students asked a pretty cool question about the sun. So if you're watching this, Lawanda's granddaughter, this video is for you. So enjoy. So Lawanda's granddaughter's question was, why is the sun red in the morning? And the answer has a lot less to do with the sun. It does have to do with the sun, but it has a lot more to do with what's around the sun, which is, and all the stuff that's around the sun, at least in the sky, is the atmosphere. So this video has a great deal to talk about the Earth's atmosphere and how that can change the sun's color. So let's start with a picture of the sun from space. So this is taken from one of our space stations in orbit around the Earth, probably the International Space Station. As you can see in this photo, we have a white sun. Whenever we see drawings or maybe a painting of the sun, usually it's white or yellow, but if you look at it from space, it's always going to be white. So yes, we have a white star that the Earth orbits around. And we know that if we take white light and put it through a prism, we see what we refer to as a rainbow, which we can divide into 6 main colors: red, orange, yellow, green, blue, and purple. And not the first person to discover this, but definitely one of the first people to experiment with this extensively was Isaac Newton. Isaac Newton worked a lot on tinkering with how white light can be divided into these 6 main colors. He actually has a 7th one in there between blue and violet called indigo, but we're not going to make things more complicated than they need to be. Okay, so before we talk about a sunset, or sorry, sunrise, let's just talk about the sun in the middle of the day. So here we got the sun in the middle of the day. Maybe it's noon, I don't know. So one thing we got to remember is that the atmosphere is made of things. There's lots of things that make up our atmosphere. The things I'm going to talk about are oxygen and nitrogen molecules. So what these oxygen and nitrogen molecules like to do is they like to scatter light. So remember, sunlight is pure white light made of 6 colors that we can divide the white light into 6 colors. And the oxygen and nitrogen molecules like to scatter the light. They like to scatter the blue end of the rainbow. Yes, there's violet over here too, but we usually, when physicists talk about light, they kind of talk about the blue end, since we can't really see much of that violet anyway. What this does to sunlight is it takes that blue part of the sun away and makes it a little bit more yellow. So when we look up in the sky and we see a sun, we actually do see a white or a yellow sun. And where did that blue light go? Well, that blue light went into the rest of the atmosphere. So it makes the sky a blue color, even though it really makes the sky purple, but what we see is blue. And you might be asking yourself, well, if it makes the sky purple, why do we see blue? And that is actually a limitation on how our eyes actually work. And that is definitely another story for another time. So this whole effect of how the white light is scattered around the atmosphere, we left with a yellowish sun and a blue sky. This was discovered by someone named Lord Baron Rayleigh. It's called Rayleigh scattering, named after Lord Baron Rayleigh. So far, we've reviewed a few things. We reviewed how sunlight can be divided into multiple colors and how the atmosphere scatters that light. So hold on to the things as we explain the next part. So we're going back to my original question here. The original question is, why is the sun red in the morning? You can actually turn that question around and say, why is the sun red in the evening? So both questions are due to the same phenomenon, which is Rayleigh scattering, how the sunlight interacts with the Earth's atmosphere. But the last part of the question, we have to invite in some geometry, which I know is a lot of people's favorite subject. It's actually not going to be that complicated, not in this video. And if you take a geometry class, especially the school I teach at, I hope you like it. I like geometry. If you ever need help with geometry, I'll be happy to talk to you about it. But so let's answer the last part of this question with a diagram here, okay? So here's the Earth. I hope that was pretty obvious. There's you. And this blue hazy thing, we're going to call the Earth's atmosphere. So the Earth's atmosphere is not this thick. This picture is not to scale. I hope you realized that when you saw you there. I mean, nobody was really that tall. But there's the Earth's atmosphere. Again, not to scale. The Earth's atmosphere is actually much thinner, but we're just kind of doing this to demonstrate something. Okay, and here's a ray of sunlight. So here's a ray of sunlight coming in. Remember that sunlight begins white. In space, it is white. But because of raw light scattering, that white, some of that light's taken away, and what we're left with is a yellowish sun, a white or yellowish sun. So again, in space, the light is actually white, but what we see is yellowish. Okay, so now the Earth is going to rotate, and now it's 6 hours later. So maybe this was local noon back here. Now we're getting closer to sunset, and here's another ray of sunlight. So you notice that earlier, that sunlight had basically a very short distance to travel to reach you. Now, again, you're not this tall compared to the rest of the atmosphere, but the sunlight didn't have very far to travel. But 6 hours later, now the sunlight has to travel through all of this atmosphere. So again, we start with white light, but because the sunlight is traveling through so much more atmosphere, that raw light scattering effect intensifies. And that raw light scattering eats up not just the violet and the blue, but also the green and yellow and even some of the orange. And we're left with an orange or red sunrise or sunset. If you actually get out really early in the morning, or maybe just like right the right time at sunset, you can actually see a red sun rising or setting. And this works even better with the moon. If you know when the moon is going to rise or set, you can catch the moon at the right time, you'll see a red moon. It's really cool. So hopefully that should answer our question. The question was, why is the sun red in the morning? Well, it's because our atmosphere absorbs and scatters other colors from the white sun. So remember that the sun is white, and it appears different colors because our atmosphere messes with it. So the more atmosphere the sun has to travel through, the more likely it's going to shift toward the red end of the light spectrum. So white light can be divided into many colors, but the least energetic color is red, and the atmosphere likes to eat up all those higher energy colors like violet and blue. And if it travels through a lot of atmosphere, which is the case in sunrise and sunset, we lose a lot of those high energy colors, and we're left with the low energy colors, which is the oranges and reds. So I hope that answers your question. It was fun making this video. And if you had any follow-up questions about that, let me know. Talk to you soon. Bye.